I'm Dr. Beatriz Moya, an allergist from Spain, and the ACI Junior Member Representative for the Food Allergy Section. Today is my pleasure to have in this interview with Dr. Norbert Krautenbacher, who's a data scientist and previously worked at the Research Institute of Computational Biology of the German Research Center for Environmental Health. We're going to speak today about his published article in the PAI journal titled Asthma in farm children is more determined by genetic polymorphisms and in non-farm children by environmental factors. So Dr. Krautenbacher, good afternoon.
Hello.
Could you please explain the rationale of this study and what are the main outcomes?
Yes. So since asthma is influenced by genetic and environmental factors, the objective was to study these influences and their interactions on asthma in children. More specifically, the goal was to investigate whether prediction of childhood asthma depends on the environmental setting, in particular the farm exposure. And we set out to do this by exploiting modern tools from statistics and machine learning for predicting the disease, which have many advantages over classical statistical methods. And the main outcome was that looking at genetic and environmental predictors, asthma in farm children seems to be distinct from asthma in non-farm children. So asthma in non-farm children was mainly predicted by environmental determinants, whereas in farm children, genetic determinants outperformed environmental predictors. In both non-farm and farm children, the family history of asthma and atopy was a key predictor, and this determinant may integrate environmental exposure, genotype, and also the degree of penetrance.
Thank you. The methodology of your study is very interesting. So what are the methodological challenges of this study?
So yeah, there were several challenges regarding the methodology, and I will name the main ones. So first, there was a big data problem regarding the number of variables. After quality control of the genotypic data, there were still more than 700,000 of SNPs left, which were to be used as predictor variables. So this was a problem of high computational complexity that required efficient statistical learning strategy to handle such high dimensional data and also incorporate all variables simultaneously. An additional challenge was the structure of the predictor variables. We had several blocks of variables which belong biologically together. If, for example, such blocks are too low dimensional, they can be overshadowed, and therefore methods were required that include these blocks appropriately. And another challenge was sample selection bias in the data due to the study design. So some subgroups in the data were over and others were underrepresented compared to the population. So therefore we had to use strategies which correct for this bias.
And to finish, what specific environmental factors do you think could be changed to reduce the risk of non-farm children developing asthma?
Yeah, the study was focusing on farm-related exposures. So in other studies, farm-related exposures like raw milk consumption, contact with animals, or animal feed have already been found to be related to reduce the risk of developing asthma. And according to our analysis results, especially pet exposure can significantly reduce the risk of asthma in non-farm children. In particular, one of the most robust factors here was the contact to a cat during the last year, but also contact to dogs, cows, straw, and hay, amongst others, contributed significantly to the prediction of asthma in non-farm children. All these farm-related exposures reduce the risk of developing asthma. So this could be integrated into a child's lifestyle in order to lower the risk of developing asthma.
Okay, thank you very much for being with us today, Dr. Krautenbacher. You can access his article by clicking the link below.